Hello everyone, this is Vijayasri working as an assistant professor, Department of CSIT, MLR Institute of Technology. In the previous session, we have discussed about what is SMA, DMA and functions of DMA. In that, we have discussed about LEC function. In today's session, we'll discuss about CLOC and realloc. Before that, what is DMA? DMA means dynamic memory allocation. Means we are allocating the memory dynamically from the heap section using malloc, mloc, cloc or realloc. Not only that, we need a pointer to use these functions. We need a pointer. So, in DMA, the memory is allocated at runtime. In SMA, the memory is allocated at compile time. In DMA, the memory is allocated at runtime. Means in SMA, the memory is fixed. We cannot increase or decrease the memory. But coming to DMA, based on the programming needs, we can increase or decrease the memory using the mloc, cloc, realloc functions. On successful allocation of memory, these functions returns a base address. To store that base address, we need a pointer. After we are done with that memory which is allocated by using these functions, we have to deallocate the memory using a free function. Free function syntax is just we have to write on a free and here the pointer name. So in DMA, the memory is allocated at a runtime. Now, CLOC function. CLOC means contiguous memory allocation. Mainly this is used for, generally it is used for arrays. Then, this function is also present in the header file stdlib.h. Done. On successful allocation of memory, it returns a void pointer. If it is not allocated, it points to null. It takes two arguments. And coming to mloc, the default value is garbage, as we discussed in the previous session. But in CLOC, the default value, all the bits are initializes to 0. The default value of CLOC is 0. Then syntax. Syntax is on successful allocation, it returns a void pointer. Then the function we are using here is calloc and it takes two arguments. That means how many number of blocks you want to allocate, comma, which type of data, size of data type, which type of data you are storing. Based on that, we have to use size of operator, then data type. Suppose consider an example like I want to store, and one more thing, it will allocate, the memory is allocated as multiple blocks. In mloc, single block of memory of, let us suppose 8 bytes. 8 bytes of single block is allocated. But coming to CLOC, multiple blocks of memory of same size is allocated. So suppose I want to store a character values, then this void pointer must be typecast to the char pointer because I am storing a character values. Then the function used here is calloc. Then suppose I want to store 5 values, then number of blocks are 5. Then size of data type. Here the data type I am using is character. So character occupies 1 byte of memory. That means it allocates 5 bytes of memory to store character values. On successful allocation, it returns a base address. Suppose the base address is 1000. It returns a base address. To store that, we need a pointer. because pointer is having a property to store, to hold the address of another variable. So it points to here. If the memory is not successfully allocated, it points to null. And this memory is allocated from the heap section. Then example program, read and print 1D array using a calloc function. So this calloc is present in the header file stdlib.h. Here I included stdio.h because printf and scanf is present in that header file. Then I am using a calloc function to allocate memory dynamically from heap section. So this calloc is present in the header file stdlib.h. On successful allocation, it returns a base address. To store that, we need a pointer. Here I am storing integer type values. So int pointer, n is the number of blocks, then I. So number of blocks are 4 suppose. So int, I am on successful allocation, it returns a void pointer, calloc. But I want to store integer values, so I have typecasted that into int star calloc. Here n is the 4 comma size of int. Size of int, where size of integer is 4. So 4 comma 4 means it allocates 4 blocks. 1, 2, 3, 4. 4 blocks, multiple blocks of same size. Each is of 4 bytes. Each is of 4 bytes. On successful allocation, it returns a base address. So we need a pointer to store the, it is pointing to here. So suppose here we have 1000. Then if not, it has to point to null. So here I consider if condition ptr equal to null, memory not allocated. Then I equal to 0, 0 less than 4, condition is true. Then the value that is 10 has to be stored where ptr plus I, where ptr is 1000, 1000 plus I is 0, but which is of integer type, then 0 into 4 because integer occupies 4 bytes of memory. Then the value 10 is stored in the address 1000. Again I plus plus, now I becomes 1, 1 less than 4, condition is true. Then the next value that is 20 is stored in the address ptr plus I, that is ptr value is 1000. Here we have plus 1 is, I is 1, whereas it is integer type values I want to store. So int occupies 4 bytes. So the next value is stored in the address 1004. So here we have 20. Again I plus plus, now I becomes 2. Each occupies 4 bytes, 1004, 1008, then 1001. Again I plus plus, now I becomes 2, 2 less than 4, condition is true. Then the next value that is 30 has to be stored in the location 1000, ptr plus I, 1000 plus where I is 2, 2 into 4. Why? Because why we consider here 4? Because int occupies 4 bytes of memory. So the next value has to be stored in the location 1008, that is 30 is stored here. Then again I plus plus, now I becomes 3, 3 less than 4, condition is true. Then the next value 40 has to be stored in the location ptr plus I, where ptr value is 1000, I is 3, where it is I'm storing a integer type value. So int occupies 4 bytes of memory. So in the location, the value 40 is stored in the location 1012. Again I plus plus, now I becomes 4, 4 less than 4, condition is false. So the control goes to the next in a sequence. In a sequence we have another loop. Whatever the values I stored in that memory location, I want to print those values. So for I equal to 0, 0 less than n is number of blocks allocated is 4, 0 less than 4, condition is true. Then I want to print the value which is stored in this particular location. So to print the value, we need a dereference operator. Then ptr is 1000 plus I is 0. Which type of value I want to print? Integer value. So it is 4. If you want to print a character value, then star, suppose the address is 1000, 0 into character type of value. If you want to print the data, the size occupied by character value is 1, because 1 byte is allocated for the character type values. Then 1004, in 1004 the value is 10. It is going to be printed. So here it printed. Again I plus plus, now I becomes 1, 1 less than 4, condition is true. Then I want to print the value which is stored in that location, that is 1000 plus I is here 1, and the value is of type integer, size occupied by that is 4 bytes. So in 1004 address, the value is 20. 20 is going to be printed. Then again I plus plus, now I becomes 2, 2 less than 4, condition is true. Then in the next location, that is star PTR, PTR is 1000 plus I is here 2, whereas it is of type integer, so 4 bytes is allocated. So 2 into 4 is 8. Then the next value I want to print in the location 1008. In 1008 I have 30, 30 is printed. So here we have a 30. Then again I plus plus, now I becomes 4, 4 less than 4, condition is, now I plus plus, I becomes 3, 3 less than 4, condition is true. Then I want to print the value which is stored in the location star PTR plus I, where PTR value is 1000 plus I is here 3, whereas it is an integer type. For int it is a 4 bytes, so 1012. In the location 1012 I have a value 40, that is going to be printed. So using a calloc function we can read and print the we printed array elements using a calloc function. Here the calloc takes 2 arguments, and this function is available in the header file stdlib.h. The difference between malloc and calloc is malloc takes 1 argument, calloc takes 2 argument, and the default value of malloc is garbage and the default value of calloc is 0. And these 2 functions are present in the header file stdlib.h. Then next we have a realloc. Realloc means reallocation of memory. If the memory is allocated by malloc or calloc. If the memory is allocated using these 2 functions, then we can reallocate the memory using realloc. Here we have a syntax. The return type of realloc is also void pointer. Then this is the size of a old pointer. Then a new size. So here first I have used a calloc function to allocate the memory in a heap section. Then so calloc, it takes 2 arguments, so n comma size of data type. Then this is stored in the variable pointer, that is a pointer variable a, and then I am reallocating the memory, that means resizing the memory. Either we can decrease or increase the memory if the memory is allocated by these 2 functions. Then I am resizing that, the old using a realloc function. Then the old pointer is a, and the new size is I want to increase or decrease 2 blocks of memory of data type int. Then coming to the example of realloc. So here realloc is also present in the header file stdlib.h. On successful allocation, it returns a base address. To store the base address, we need a pointer ptr. Then n1 is the size which is allocated by malloc function malloc. Then n2 is the new size. So first, if we want to use a realloc, we have to allocate the memory using malloc or calloc. So here I have considered malloc function. So the new size here I have, the size allocated, the number of blocks allocated by malloc is 5. I am not printing the value, here I am printing the addresses. Then address of previously allocated memory, that is I is 0, 0 less than n1 is 5. So to print the address we need a format specifier %PC, which is used to print the address of that memory location. So ptr plus I, suppose it is 1000 plus I. So here we got. Then I am reallocating the memory using the new size. I want to decrease the memory. Initially it is 5 blocks which is allocated by malloc. Then I am resizing that, reducing this to 2. So then newly allocated memory, reallocating the memory using a realloc function, we can reduce that, the previous pointer. Here we have the previous pointer comma new size. N2 is the new size, so I want 2 blocks, only 2 blocks, I don't want the remaining 3. Then 2 into size of int, whereas integer type values, so that's 4. So new, it is reduced to 2. So here we have 2 blocks, the remaining 3 are not there. Like this we can increase or decrease the size of the memory in a heap section when the memory is previously allocated by malloc and calloc function. To do that, we are using a function called realloc. To print after resizing, after reducing it to 2, I have printed the addresses. So using the format specifier %PC. So in this session, we have discussed about calloc, calloc and realloc functions. In the next session, we'll discuss about strings. Thank you.